This playlist has covered many topics, so let's review the key points. The workflow to run a program on an access resource using SLURM is, first, build your program from its source, or ask your RP to install it. If you build it yourself, you may need to load a module before it will build. Second, create a SLURM job request script for running your program. If your program requires a module, that is, if a particular module was needed to build it, then your script will need to load that same module. Third, submit your script to SLURM using the sbatch command. Once you've done this, you can check its status using the squeue-j job number or squeue-u username command. If you decide to cancel it, you can do so using the scancel job number command. When your program finishes successfully, the output file specified in your job request script contains anything your program would have displayed on the screen. If your program instead wrote its results to a file, SLURM will not change that. The results will be in that file as normal. Different computers understand different binary languages, so runnable binary programs are not generally portable. For portability, many open source projects distribute the project's source code with a make file. A person can then run the make utility to build a binary program for their computer from its source code. If the make file uses tools that an access RP has stowed in a module, you will need to load that module before make can build the program. To learn more about make and make files, use your favorite search engine to search for make tutorial. On access resources, multi-version software is usually stored in modules. Such modules must be loaded before the software they contain can be used. Different RPs use different naming schemes for their modules, so ask your RP what modules they recommend for building and running your software. If a module was needed to build your software, it will also be needed to run your software. So your SLURM job request script should load that module. In our demos, we loaded modules for Intel's HPC software, free open source software, and NVIDIA's CUDA software. New software versions appear frequently, and there's no standard by which RPs name their modules. So ask your RP what modules they recommend you use for your project. SLURM job requests are submitted using the sbatch command, followed by the name of a job request script file. Its details vary with the kind of job. OpenMP jobs consist of one process with T threads, all of which run on a single node. Since it has one process, it needs just one node and one task, but it should request T SLURM CPUs so each thread gets its own core. MPI jobs consist of multiple processes running on one or more nodes. Each core of each node can run one MPI process. So to run n times p parallel processes, specify n nodes with p processes per node, minimizing the number of nodes. For example, to run 128 processes on faster, I would use 2 nodes, each running 64 processes. CUDA, or OpenACC, jobs offload most of the computation to the GPU, so they typically consist of one node, one task, and one SLURM CPU. But they will use SLURM's GPU partition. SLURM lets you request the kind of GPU you want to use. The total parallelism depends on the number of CUDA cores on that GPU. Your resource provider's online documentation usually indicates the number of CPU cores and memory on a compute node, the number and kinds of GPUs they have available, and so on. If questions arise, don't hesitate to submit a help request ticket to your RP through the Access support site. We would like to thank the U.S. National Science Foundation, whose support made these presentations possible. We would also like to thank the Texas A&M University HPRC Help Desk team, who answered our questions about using FASTR. We welcome requests and suggestions. To provide feedback, please go to access-ci.org/about/contact. Last but not least, thank you for watching these presentations. We hope they help you advance and accelerate your research.